Okay, so in this video we're talking about finding the limits of a function. So we're going to have some type of an equation. We're going to do it looking at a graph, like it says, graphically, and we're going to do it looking at numerically. So numerically is here in our table. We're going to do some analyzing and see. So our first one says here, we're going to use our calculator to complete this table, and this is your function that we're trying to evaluate. Okay, it is square root minus 1 over x plus 3, as we're trying to figure out what is happening to that graph at when x is negative 3, right? So there's some nomenclature, there's some notation that we have to figure out. So we're trying to find out what is the y value, right? What is the y value from the graph when the x value is negative 3? Okay, that's the question we're trying to answer by looking at this limit. Okay, and then we have the square root of x minus 4 minus 1 over x plus 3. Okay, so we're going to learn in a little bit that we're going to figure this out basically by plugging in, right? It's called direct substitution. We're going to directly substitute whatever that x value is into your equation. Okay, and if we do that, we get negative 3 plus 3. Well, that turns out to be 0. And then we have negative 3 plus 1. Well, that's 1. 1 minus 1 is 0. Right? So technically at negative 3, we have an undefined function because you have something divided by 0. Right? There's not a y value there. But we can still find the limits at negative 3 even though there's not a y value. Y is not defined at negative 3. And we're going to do that by looking at this table and figuring out what's happening here at negative 3. So we have the right of negative 3, right? Negative 2.999, negative 2.9. Those numbers are to the right of negative 3 on the number line, and all these numbers are to the left of negative 3 on the number line. So we're going to see if these two numbers here are looking like they are going to be about the same, right? And if they are the same, then that value is going to be what we call the limit at x equals negative 3. Okay, so let's use our calculators, and we're going to plug in negative 3.1 and negative 3.01 and negative 3.001, right? Numbers getting closer and closer to negative 3 into this function over here, and we're going to estimate, or we're going to round to, let's round to 4 decimal places. Okay, so I'm going to pause here and do that work. So as we look at these numbers, from the left, we're getting at 0.51 and then 0.501 and then 0.5001. So it looks like these numbers are getting closer and closer to 0.5 or 1/2 as we get closer to negative 3. And then from the right, approaching from the right, we have negative 4.88 and then 4.99 and 4.998. So it looks like both of these numbers are trying to go to what single number that would be in the middle? 0.5 or 1/2. Right? So from our numerical standpoint here, from this table, we could say that the limit as x approaches negative 3 of this function looks like it's going to go to 1/2. 1/2 is going to be the limit. That's the y value that the table is approaching from the left of negative 3 and from the right of negative 3. Okay, it won't always be that way. It might go to different numbers, in which case you don't have a limit. If the left side and the right side are both going towards negative 3, then that's the limit. So graphically, that might look like this. Okay, so here's positive 1, here's negative 3. Right, so 1/2 was going to be your y value. I don't know what the graph does, but it might look something like this. So from the right side, we are approaching 1/2. From the left side, our y values are also approaching 1/2. Okay, so we could look at the actual graph on your calculator, and you might see that the graph looks like it's going towards 1/2. Okay, we'll look at an example of that in the middle, or in a minute. Okay, then the next one says, create a table and use the results to estimate the limit. So here we're not giving you any x values, but the limit we're trying to approach is 0. Okay, so if 0 is going to be the number in the middle, then we might have, what's a number a little bit smaller than 0? Negative 0.001, and then maybe negative 0.01, and then negative 0.1. And then on the other side, the positives, positive 0.001, positive 0.01, and positive 0.1. Okay, so this is the limit of sine of 4x divided by x. And of course, if you plug in a 0, we get a 0 on the denominator, and also the sine of 0 is 0. All right, so we have this 0 over 0 business. So let's do the same thing. Now we have a trig function, sine of 4x divided by x, and let's see what those y values look like they're going to approach. So evaluating this table, this is 3.89 and 3.99 and 3.999. Right? It looks to me like these numbers are getting closer and closer and closer to 4. So we'll say the limit as x approaches 0 of sine 4x over x is going to be 4. Okay, that's the y value that the graph is approaching as x goes to 0. Okay, so let's look at this as a graph real quick. So this is what the graph looks like on my graphing calculator. It looks like right symmetry. There is definitely left and right symmetry. This is y-axis symmetry. But on the graph, you see that it looks like it's continuous, but probably at 0 here, it should have an open circle because y is not defined there. 0 is 0, so probably going to be an open circle there. But from the left side and the right side, the graph is approaching the y value of 4, which means the limit at 0 is 4. Even though there's not a y value there, the limit, the graph is approaching that positive 4, so that's going to be the limit of that graph. Okay, so the limit in graphical speak is the y value that the left side and the right side of the graph are approaching for that given value of x. Okay. So let's see about this one. This one is a piecewise function. So we have two things that we're going to graph. The first one is x squared plus 1 as long as x does not equal 2. Right? So every other number in the world except for 2, we're going to graph the x squared plus 1 graph. Okay? So this is your standard parabola that has been moved 1 unit up from your origin. Okay, so let's see if we can do that. Here's our graph. Standard parabola that's been moved 1 unit up. So this is our vertex. And then maybe you've memorized the pattern. So for a parabola, we go over 1 unit and up 1 unit on both the left and the right side, and that gives us our second parabolic points. And then you go over 2 and up 4, right? Because 2 squared is 4. So here's your pattern. 1 over 1 up, back to the origin, 2 over 4 up. So here is the graph of your parabola, right? That top one, x squared plus 1. But the graph said except for at -2. So at -2, we're going to have to erase this point because that point does not exist on our graph. So we're going to put an open circle here, right? Because at -2, we don't do the x squared plus 1 graph. Okay, what do we do at +2 instead? At +2, the y value is 3. Okay? So everywhere except for at +2, we follow the x squared plus 1. When it's +2, the answer is 3. So we put in a closed dot, right, just a dot. They're at the coordinate 2, 3. When the x value is 2, the y value is 3. Okay, so that is a graph of our piecewise function. It's x squared plus 1 everywhere except for at positive 2. And when it's positive 2, we have the point at 3. So let's see what we're asked to find. We're asked to find the limit as x approaches 2. Okay, so what we're going to do is follow the graph. Right? Whenever we're trying to find this graphically, we're going to follow the graph and move your pencil along the graph towards positive 2. So we're going to come from the left. If we follow the graph, and I'll change colors so that we can see. If we follow the graph from the left to the right, the graph is approaching what number from the left? What is that y value? 1, 2, 3, 4, 5. Right, so from the left, the graph is approaching a y value of 5. And from the right, the graph is approaching a y value of 5, right? It looks like those are going to the same place. If these are two airplanes flying in the sky, there would be a problem because they're headed towards the same point. They're going to crash nose to nose. So what is the graph approaching? What y value is the graph approaching when x goes to 2? The answer is 5. Okay, so we're not really concerned about the coordinates so much as we are about the graph. What is the graph approaching at we go to the x value of positive 2? Okay, so that's a limit, right? We're looking at the graph of a function as it approaches a certain x value. Okay, here we have this strange one, the absolute value of x plus 3 divided by x plus 3. Okay, do you know what that looks like? Probably not. So let's make a table of values and let's see if we can graph this. Okay, so here we have a table. Let's do -5, -4, -3, and then -2, -1, and 0. Okay, so we're going to plug in these y values, or these x values, and we're going to get out a corresponding y so that we can make a sketch of our graph. So here is our graph of absolute value x plus 3 over x plus 3. So let's evaluate, let's look at it as x approaches -3. So from the left, what is the y value that we are going to as x approaches -3? From the left, it's -1. Right? That's the y value here. That's a y value of -1. So from the left, our graph is approaching -1. But from the right, our graph is approaching what value? +1. So does the left y value and the right y value equal each other? Right? No, one is going to -1 and one is going to +1. They're going to different places. So we say that the limit here does not exist. Okay, so let's scratch off the equal sign because the limit does not exist. The limit at -3 does not exist. Okay, so we use the three letters D and E. So that's where we're going to come over here, maybe on this side, because we're going to use D and E a lot. Right? We all learned from Mean Girls that the limit does not exist. So D and E stands for does not exist. Okay? When the left side and the right side do not go towards the same y value, the limit does not exist. Okay? All right, let's see what the second page of notes has for you. Okay, so here we have a nice graph. Definitely a piecewise graph. There are pieces of lots of different functions on here. And we're going to evaluate it at different things. Okay, so here's our graph. Open circle, closed circle, open circle. This is, of course, an asymptote. So it's not defined at 5 and it's not defined at -3. So we're looking at this graph. So we're going to use our graph to, well, do whatever it says that we want to do. So what is f of 0? F of 0. What is the y value when x is 0? Hopefully you're saying it is -4, right? That's the closed dots. When x is 0, we're looking for the closed dot on your graph. The closed dot is at -4. So the y value when x is 0 is -4. Okay, what is f of 1? Right? Is there a closed dot on the graph when x is +1? No, this is an open dot, so the f of 1 is undefined. Okay, there is no y value that corresponds with an x value of 1. There is an open circle there, so there's not a y value. We say that that point is undefined. Okay, how about the limit as x approaches 0? So for the limit, we have to look at two different directions. A direction from the left, which we're going towards, I don't know, what is that, 3/4 or something, maybe positive 3/4. From the left, we go to 3/4, but from the right, we go to -4. So if our graph is not going to the same place, our answer is does not exist. The limit of our graph at 0 does not exist because the left side of the graph and the right side of the graph do not go to the same y value. Okay, how about at +1 though? What is the limit of our graph at +1? So from the left side, our y value is approaching -1, and from the right side, our y value is also approaching -1. So as long as the left side and the right side are approaching that same y value, then that is the limit. Even though our graph does not exist right there, the limit does. Right? The graph is approaching a y value of -1, even though it's never going to actually reach -1. Okay, what about at -3? What's the limit at -3? So here's something we haven't talked about yet. If we go towards from the left side and we follow this graph, where is it going? Up to infinity, right? We're going to assume that that graph continues on forever. But as you go from the right side, our graph is going towards what value? -infinity. So is -infinity and +infinity the same place? No. So that means the limit here does not exist because the y values do not approach the same thing. The graphs are going in opposite directions. But what would you say about at 5? From the left, the graph goes up, and from the right, the graph goes up. Are those the same place? Yeah. So for the limit as x approaches 5, the function goes to +infinity. As long as your graphs are going to the same place, then the limit is at that place. So we can have infinity limits, we can have numerical limits, or we can have limits that do not exist. Okay? And those are, right, how we look at these things graphically and numerically.